All right, so in this video here, we are going to be looking at the review questions for your final exam for Chapter 8. And so I have the questions here kind of handwritten, copied, shorthanded from the book. And so I'm starting on the supplemental exercises for Chapter 8, which are starting on page 338. So there's a steel company. They make iron rings. Usually they're about 24 inches in diameter, plus or minus a little bit. So there's some variation, some standard deviation, and they take samples of size 25 and test them. And they calculate a 99% confidence interval. And if they can find evidence that the lower bound is less than this or the upper bound is greater than this, then they stop that production. And so they took a recent sample here of 24, recent sample of size 25, and they got 24.015, and it's like, do we need to stop production here? So we need to create that 99% confidence interval on X bar here to figure out if we need to stop production or not. So confidence interval equation for sample mean with standard deviation known, we can use the Z distribution, and then you'll do sigma over the square root of n. Now let's go ahead and find the critical value for a Z for a 99% confidence interval. Well, remember, 99% confidence interval, 1% would be left over, and we'd have to divide up that 1%, right, on either side here. And so that's the right tail test we're going to look for, or right-tailed probability we're going to look for. And I'm going to use my t-chart and this go all the way down. So I have here 0.005, and then if I look under infinite degrees of freedom, that's going to be my Z. So 2.576. 2.576 is my critical value for Z. All right, so let's go ahead and do this. 24.015 plus or minus, we said 2.576. Standard deviation all over the square root of n. So let's go ahead and calculate just the margin of error first. Okay, so my margin of error is 0.03. And so if I have 24.015 minus 0.030912, I get 23.984, which is within my lower bounds region, barely, but it's there. And then 24.015 plus that margin of error gives me 24.046. Now look at that. That upper bound is going to be larger than this. Barely larger, but it says if it's larger, we need to stop production here. Okay? So that's going to be our conclusion because the upper bound is larger than it is supposed to be. All right, the next question on the review is 8.77. There was a survey of 500 randomly selected adult men, and the mean time that they watch sports on TV per week is 9.75 hours, and then that gives the standard deviation of 2.2. Construct a 90% confidence interval for the mean. Now, because this is a survey and I don't know sigma, I just know S, I'm going to have to use the T interval because I'm using an S of 2.2 to approximate the population standard deviation here. Okay. All right, so we're going to use the exact same formula here, just we're going to use S instead of sigma. So that's going to be 9.75 plus or minus, let's go look up the Z-score for 90% confidence. Okay, so I'm going to look at a right tail of 0.05, 1.645. Times the standard deviation S all over the square root of n. All right, let's find our error first. Okay, so our error, margin of error is 0.1618. And then I'm going to add and subtract that to my mean. Oops. Okay, and so my interval here ends up being 9.588 to 9.912. And our units would be hours. Now remember, you can do this on your calculator as well. If you go to stat and then go over to test and you go all the way down to t interval, okay, we have the statistics, and you just plug in those statistical outputs here. And it uses the programming to find the interval for us, okay? All right, 83 is the next question here. So 90% confidence interval for the mean cost of houses in a state. How large of a sample do we need? I don't know how large. So the estimate is within that. Okay, so that is our error. Okay, and then we're assuming our standard deviation here. So we're just using this error piece here. So a 90% confidence interval, we already know that critical value is 1.645. I'm using my standard deviation here over the square root of n. Okay, and I'm going to say let that be equal to my error, which is 3,500. Now I can solve this for n. I do know the book gives an equation for solving this, but I kind of find it easier just to remember the error part of the confidence interval, and then you don't have to worry about writing two equations down. All right, so I'm going to multiply by square root of n and then divide by 3,500, and then I'm going to square for my final answer here. So 1.645 times the standard deviation divided by 3,500 and then squared and round up. So n should be 220. All right, let's keep working these questions here. So city is considering legalizing casinos. City council wants to estimate the proportion of all adults who favor. In a preliminary study, 63% favor. How large of a sample should be taken for a 95% confidence interval for a margin of error of 0.05? So this is still going to follow the exact same outline as means, but we're now talking about qualitative data because we're talking about, do you favor this, yes or no? And so remember, our equation is going to be p hat plus or minus still z, but our standard deviation uses the standard deviation for proportions here. And then this piece here is our error, right? That's what we're going to be using to solve this question. So let's set that up. 95% confidence interval has a critical value of 1.96. And then I'm going to use that pilot study here. Okay. We're now going to solve this for n. Different than when we did this with means, you're actually going to divide by 1.96 first. Okay, and then square both sides. So I get a really, really teeny number, which is always going to happen. 1, 2, 3, 6, 5, 0, 7, 7. Okay, so now to solve this for n, we're going to multiply n over here and divide here. And so how I like to do that in the calculator is I like to say, okay, in my numerator, I have this multiplication, and then divide by that answer that I just got. Okay, and it will find the n and always round up for margin of error questions. All right, next question here. There's a bunch of yeses and nos on the data, and it says random sample of 20 managers. Do you take work home? Create a 99% confidence interval for the percentage of all managers who take work home. Again, this is a qualitative data question, so I'm going to use proportions here. So let's count the number of yeses. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 20 is my sample proportion here. 8 out of 20 is 0.4. So we're going to say 0.4 plus or minus a 99% confidence interval has a critical value of 2.576. And then we're going to use our sampling distribution standard deviations for proportions here in order to find this interval. All right, let's calculate the error here. Okay, so that's my error. That seems really big, yeah. So 0.4 minus that, 0.4 plus that is 12 to 68. Now the reason why this margin of error is so large and why my interval is so large is n is actually pretty small, okay? And in some of our other questions have been, 100, 500, and so the larger your n, the smaller your error, and the smaller the width of your interval here. Now, if you wanted to check this in your calculator, you would go under Stat and Tests. And again, you don't want to do that z interval. You want to do proportion z interval here. Okay, you just tell it the number of successes here and then the confidence level that you want, and it runs the programming for you. And you can see we did it all correct here by hand. All right, there's also some self-test questions that I want to make sure I do in this video with you. So if we have a random sample of 36 vacation homes, mean cost, and then it gives us the population standard deviation. Your point estimate is your mean, okay? That's just vocabulary you need to know. And then for the 99% confidence interval, we're going to take that mean, plus or minus, I'm going to use my critical value for 99%, and oops, it's only square root of n. And then standard deviation over square root of n. All right, let's calculate our error here. 2.576 times 27,000. Divide that by the square root of 36. Okay, and so my error is 11,592. And then I can go ahead and add and subtract that to get my interval here. All right, let's keep going with these questions. There are 3 more for our video here in the review. All right, random sample of 25 lawsuits versus doctors have a mean compensation. Now, important here, this is the sample standard deviation. I do not know the population standard deviation, so I have to do a t interval. I have to use the t distribution because I know S, not sigma. 95% confidence interval for the mean compensation. So I'm going to use X bar, given to me here in the problem, plus or minus confidence level of 96 has a critical value of 1.96 times standard deviation over the square root of n. Okay, and then we would go through and find this here. Okay, so my error is 37,000, and now I just add and subtract that. Here. Okay, and again, you can always check your answer by running a t-interval. Okay, and it will do exact values. We're pretty close here. Okay, it takes into account the correct t distribution to use here. I went with the default 1.96, which is also the z. Okay, and this is going to account for degrees of freedom of 24, and be a little bit more exact if you use your calculator instead of just using the table. Okay. All right, an online poll, 37% said they have lied to get out of work. Okay, so this is again a yes/no question. So we're looking at proportions here. So my point estimate is 0.37. I'm now going to use that to create this 99% confidence interval. What would that be? 63 all over n. Oh, it must have given me n in the problem. I don't know n, but this is the same kind of question, okay, that we have done in the past. Okay, let's do one more margin of error question. Toaster oven temps are going to vary. Previous studies give a standard deviation of 5.78. How large of a sample do we need to estimate the mean temp within 1.25 degree with 95% confidence? So 95% confidence, I'm going to use 1.96 as my critical value. Standard deviation over the square root of n, and set that equal to 1.25. I'm then going to solve this for n and make sure that you always round up for margin of error questions. And that does it for the review questions on confidence intervals, which is chapter 8.